All right, the last thing we're going to learn about simplifying radicals is simplifying with a multiplier. Okay, let's look what this looks like. Here are your examples. Looks like this. So the only difference, okay, and this is a really easy difference, is there's just something being multiplied on the outside. So we're going to do everything we would normally do with square root of 98, and then we're just going to multiply this 3. The key is just not to forget it. So what I like to do is kind of the same thing we learned when we were multiplying polynomials. Like, I'm just going to draw a little arrow just so I don't forget, right? Like the 3 is going to come back at the end of the problem, somewhere down here. I'm just going to put it here for now. I might have to move it around, right? But this is just so I don't forget. So 98, the short way or the long way is fine here. I look at 98 and I think, oh, something that multiplies to 98, I don't know, right? That's not a number that I have like good facts memorized for, okay? But what I can do is say, oh, it's even. So let's just go ahead and divide it by 2. Okay, 2 is prime. Let's see, 98 divided by 2. I can even just like do this, right? 2 goes into 9 4 times. That's 8. And then 2 goes into 18 9 times. Oh yeah, 49. Okay, I could have thought of that, right? 100 divided by 2 is 50. So if I take away a 2 from 100, then I have 1 less 2, 49 2s. And maybe you look at 49 and think, oh, I can do this short way because 49 is 7 squared. Or maybe you just don't catch it because you're just in your little routine. Either way is whatever, right? This is my prime factorization. And I have 7 times 7 times 2, which means, look, remember my doubles go in their own house and my singles go in their own house because 7 times 7 is the square root of 40, is 49, right? And then this becomes the square root of 49, and so that's just 7, right? And then this 2 doesn't simplify, and you might think, I'm done. But I remember, oh yeah, there's this 3 on the outside. So what I do is I just take that 3 and just multiply it by whatever's on the outside. In this case, it's a 7. 3 times 7 is 21. And this root 2 does not get touched. We do not multiply this 3 on the outside by the 2. Remember, this isn't really the number 2. It's like some garbage decimal that I can't do anything with. Okay, so that's my first answer here. And then let's go ahead and just try a long, complicated one. And we're going to see that it's just long, you know. We just got to be a little organized, be a little neat, keep it nice and like organized and in a line so that we don't lose track of anything. Okay. Again, this negative 5x on the outside is not going to get used until the end. So I'm just going to put it here so I don't forget it. And then look, when you look at this, hey, do you see anything? You see like 36 is a perfect square. Like 36, the square root of 36 is just 6. You could just, right now, just look at this and cross it off and just put a 6 on the outside right here. You could just do it right now with this negative 5x, okay? You could totally do that right now. Now, for the sake of just, I'm only going to do one more example. I'm going to go ahead and like pretend I didn't notice it was a perfect square, right? And I'm just going to say, oh, it's 6 times 6. Look, I'm not going to factor it all the way down into 2 and 3 and 2 and 3, okay? But let's just write this out so you can kind of see what it would look like, right? It's going to be kind of a long one, okay? So let's just say, again, I didn't realize this was a perfect square, and I'm just going to write like this. Okay, this is 6 times 6, look, times x times x times x. There's 3 x's, there's 4 y's, and these multiplication dots are feeling a little unnecessary, but it's okay. Okay, and remember what we do here, right? And again, this is just waiting outside for us to not forget it, right? And remember, we have our doubles. Ooh, look, this is not a double, that's a single, right? There's 3, so a double and a single. Double, double. Notice I have to be really neat here. It would be really easy to lose track of one of these, okay? So then, remember, we have our doubles go in their own house. So all these guys go in their own house. And then this is the only thing that was a single. Okay, so now, look, remember, this is 6 times 6 is 36. The square root of 36 is just 6. The same thing happens with the x. And remember, the reason is we don't know what x is, but let's say it's 4. Well, x times x is 4. This is, 4 times 4 is 16. The square root of 16 is 4. So whatever this number x is, if I square it and then I square root it, square and square root are opposites, it's just going to end up being the number x. Okay? Same here. This is just going to end up being the number y. This is going to end up being the number y, right? We don't know what that is, but it's some mystery number. And then this single number x, this is what doesn't simplify. Okay? And then I'm going to bring this negative 5x down right here, okay? And now we're just going to multiply everything together. So negative 5 times 6, those are my numbers. I'm going to write negative 30. Then look, this is x times x. There's two x's being multiplied here. This is y times y. There's two y's being multiplied here. And then the only thing that didn't simplify was this square root of x. So my answer looks like this.